The following presentation is brought to you by Discovery Education, leading the world of digital and video learning. Discovery Education. Connect to a world of learning.
Think this resembles a giant stone comic strip? Actually, these images are the written language of ancient Egypt. Communication. It's the wonderful way we express ourselves, our stories, and our ideas. I'm so excited to communicate the greatest inventions in communications. We start with the ABCs and continue all the way through the XYZs before addressing some pressing matters with Mr. Gutenberg and his movable type. Then we go electric as we witness the invention of the telephone and log on to today's modern computers. Finally, we get totally wired with fiber optics and the internet. I'll be right with you. Sorry, I was so busy communicating, I didn't realize you were here. Hold on. Right now? Good, thanks. It's time. Grab your camera, your cell phone, your pencil and paper. You're going to want to record your experiences on this extraordinary journey through human expression. Communication, up next. Communication is about sharing information, ideas, stories, news, music, recipes, TV commercials. There are a lot of ways to send messages. Even two cans connected by a string will do the job.
Please continue to hold.
But no matter how the message is transmitted, it must be in a language understood by the sender and the recipient. Alphabets made language visual and opened up tremendous possibilities for communication. Excuse me. I'm busy right now. The ability to communicate through language and speech rather than through noises or gestures is one of the things that separates humans from other animals. The development of written communication made it possible for humans to share words across distance and time. Words can be recorded and transmitted later. Historians believe several cultures developed writing systems independently at about the same time. Some of the oldest known writing appeared in Egypt around 3000 BC. The ancient Egyptians created hieroglyphics, an elaborate writing system made up of about 700 hieroglyphs or symbols. They wrote their symbols in rows or columns and read from left to right or right to left. Hieroglyphs of animals or humans faced the beginning of a row, so a reader would know where a line started and which direction to read. Common symbols were birds and parts of the human body. The Egyptians referred to hieroglyphs as writing of God's words and used them to decorate the walls of pyramids, temples, and tombs. In Mesopotamia, the Babylonians wrote using cuneiform, a system developed by the Sumerians also around 3000 BC. The Babylonians communicated their ideas with ideograms or drawings. They carved them onto soft clay tablets with a stylus or a blunt reed. Then they left the tablets in the sun to harden. The stylus left wedge-shaped impressions, which led historians to call the writing cuneiform or wedge writing. The Egyptians also created papyrus, a kind of paper made from a reed that grows in the marshes near the Nile River. Papyrus reed was cut into thin strips, soaked in water, pressed together, and dried under a heavy weight. Papyrus is thin and light, yet strong enough to sustain wear and tear. The invention of paper, similar to what we use today, is credited to Cai Lun, around AD 105 in China. Cai Lun mixed the inner bark of a mulberry tree and bamboo fibers in water and pounded them into a pulp. He spread the pulp onto a flat piece of coarsely woven cloth and allowed the water to drain. When dry, the thin pulp became a flat, lightweight writing surface. In the 15th century BC, the Phoenicians developed an alphabet with 22 consonants, most likely borrowing from other writing systems. As wandering merchants, the Phoenicians needed to keep accurate, detailed records. Through trade, they introduced their alphabet to the ancient Greeks, who refined and modified it, adding symbols for vowels sometime between 1100 and 700 BC. In fact, the word alphabet comes from the Greek letters alpha and beta. The Greeks introduced their alphabet to the Romans and changed it again, eventually resembling the English 26-letter alphabet. Across the globe in Central America, the ancient Maya created a unique writing system as early as 300 BC. The Maya created elaborate hieroglyphs that included almost 800 different signs. They also made paper from bark coated with lime and created codices, or books, as early as AD 1100. Spanish missionaries burned most of the Maya codices in the 16th century and destroyed what could have provided modern historians a more accurate picture of early Maya culture. Anthropologists may never be able to put an exact date on the invention of written communication. And that doesn't change the fact that writing systems and tools for writing were dramatic developments in communication that empowered people to write laws, track financial transactions, and preserve history. From cuneiform to computers, methods of writing have changed considerably throughout time, but written language continues to be a cornerstone of human communication. Imagine a world without the written word. What would life be like if we had a limited knowledge of the cultural and scientific achievements of past generations? And how would we communicate our history and intellectual advancements to future civilizations?
Ron, how would you tell the difference between...
The written word gives us continuity. It preserves our culture.
Identify that. One would be via the color code, the other would be
Before written language was invented, stories in history were passed down orally. One generation told the next, who then told the next. Spoken language is less precise than written accounts, but writing long documents by hand was painstaking and took time, lots of time. That's why this next invention changed everything. Newspapers, magazines, maps, books, and other printed materials can be found just about anywhere. But this wasn't always the case. Books used to be rare because they were expensive to duplicate, and the materials needed to make them were in short supply. The invention of the printing press made the mass production of books and newspapers possible. The earliest known printed book dates back to AD 868. Found in a cave in China, the Diamond Sutra was made of individual pieces of paper glued together to make a scroll more than 15 feet long. It was produced using block printing, the first known method of printing. Block printing required a woodcut or an image carved in reverse into a block of wood. To print the image, a printer applied ink to the woodcut, put a piece of paper on top of the block, and applied even pressure with a brush. This created a printed image. Although time-consuming and labor-intensive, this process allowed the Chinese to reproduce multiple printed copies of the same document. In a sense, the Chinese created a rudimentary copy machine. Sometime between AD 1041 and 1048, Pai Shang invented a printing process that would later become known as movable type. Instead of a single large block, movable type used smaller cutouts for each individual character. These reusable cutouts were moved around to create unique pages of text. This meant that whole blocks did not have to be carved for each new document. In Europe, educated men called scribes tediously copied books by hand. A large number of scribes toiled in monasteries, copying thousands of documents for the Catholic Church. It reportedly took an entire year for one scribe to transcribe one copy of the Bible. All that changed in 1436 when Johann Gutenberg, a German craftsman, introduced movable type to Europe. His printing press changed the world. Gutenberg developed metal movable type. The advantage was that after the initial carving of a mold, many identical type pieces could be cast quickly. Gutenberg began the laborious process of printing the Bible in 1450. Each page required about 300 different pieces of type. 3 years later, Gutenberg had printed about 180 copies of his Bible. That's not a large number by today's standards, but it was a breakthrough in the mass production of books. Gutenberg's innovation, referred to as the art of multiplying books, spread quickly throughout Germany and the rest of Europe. The Gutenberg press was so efficient and effective that it remained virtually unchanged for about 300 years, until the dawn of the Industrial Revolution. Today, some high-speed laser printers output 45 pages per minute. This type of printer could duplicate Gutenberg's 1,286-page Bible in less than 30 minutes. Within 50 years of Gutenberg's invention, thousands of inexpensive books were in print. Access to books increased literacy throughout Europe. The widespread availability of printed materials allowed people to share knowledge more readily, leading Europe into a period of scientific, religious, political, and artistic enlightenment. Centuries later, the learning and sharing of ideas continues, thanks in large part to Johann Gutenberg.
Alexander Graham Bell's invention of the telephone truly transformed the landscape of the United States. Did you know that most telephone poles are made out of 60-year-old trees? They last approximately 12 years. In fact, if all of the telephone poles used in the United States were gathered together, they would make up a forest with an area the size of the state of Rhode Island. If the recent cell phone boom is any indication, our love affair with the telephone is in full swing. Let's see how it all began.
The cell phone allows people to talk to each other from just about anywhere, as long as they have access to wireless service. Worldwide, more than 1 billion people rely on their convenient portable phones. By 2005, cellular phones had become the most common electronic device. This innovation was made possible by the invention of the telephone almost 130 years ago. In the early 1800s, scientists made significant breakthroughs in understanding electricity and magnetism. These discoveries influenced electronic communications such as the telegraph and telephone, which allowed a two-way conversation to take place over a distance. In 1830, an American scientist named Joseph Henry rang a bell at the end of a wire by sending an electrical current down the line. Building on this achievement, Samuel Morse successfully demonstrated the one-wire telegraph in 1844. The telegraph enabled long-distance communication by turning electric current on and off quickly. Although use of the telegraph spread quickly, users had to send their messages as a series of dots and dashes through telegraph operators. German physicist Johann Philipp Reis began experimenting with the electrical transmission of sound during the early 1860s. His desire to reproduce and electrically transmit sound resulted in the first crude telephone. Meanwhile, inventor Alexander Graham Bell was working on what he called a harmonic telegraph, which would simultaneously send multiple musical notes over the same wire. Acoustics of the science of sound fascinated Bell. His father taught elocution and had invented visible speech, which showed how the tongue, lips, and throat moved to make certain sounds. Bell became a professor of vocal physiology at Boston University in 1873, and he explored how different parts of the body affect or contribute to the human voice. He trained teachers of the deaf and taught private students during the day. At night, he worked on his harmonic telegraph. On June 2, 1875, Bell and his assistant Thomas Watson were testing the harmonic telegraph. As Watson plucked at a wire to free it, Bell had his ear to the receiver and heard the distant twang. Bell reasoned if he could send one sound over the wires, he could send any sound, even human speech. Bell filed his patent for the telephone on February 14, 1876, and went down in history as its inventor. As the story goes, while testing a new transmitter on March 10, 1876, Bell spilled battery acid on his clothes and called out for Watson, who was waiting in another room. Watson heard every word Bell said over the receiver. These were the first words to be successfully transmitted electrically over a wire. Considered a novelty, the first versions of the telephone performed poorly. But within 20 years of Bell's patent, Thomas Watson, Emil Berliner, and Thomas Edison made improvements to the telephone. It remained fundamentally unchanged for the next 100 years. Bell formed the Bell Telephone Company with two financial supporters, Gardner G. Hubbard and Thomas Sanders, in 1877. That same year, the Western Union Telegraph Company entered the telephone business. With transmitters developed by Thomas Edison and receivers created by American inventor Elisha Gray, who was rumored to have applied for a telephone patent just hours after Bell, the company was renamed the Western Electric Manufacturing Company. Soon after, it became the equipment manufacturing division of Bell's company. The first commercial telephone exchange began operating in New Haven, Connecticut on January 28, 1878.
Hello. Hitching City Market, what's your name? Oh, all right, Dr. Burrow, just a minute.
The exchange had 21 customers, but the switchboard required 6 connections for each call, so it could handle only 2 conversations at the same time.
Hello. Hello. City Market? Someone wants to talk to you. Wait a minute. All right, Dr. Burwell. Here's Hitchings Market. Go ahead.
Early switchboards required operators to connect callers by physically plugging one wire into another. By 1951, automated switching and dial telephone systems began replacing most manual switchboards. Telephone operators still placed long-distance calls, but this process was automated by 1965. Innovations in telephone technology continued, including the introduction of payphones, touch-tone dialing, cordless phones, and pagers. The phone company, AT&T, introduced the picture phone in 1956 and tested it publicly at Disneyland and the 1964 World's Fair in New York. People found it difficult to use, and they thought the picture was too small. It was also very expensive. Advancements in fiber optic and wireless technology that allow speedy internet chatting have made camera and video phones a reality. For many telephone users, one of the greatest innovations was the invention of the wireless phone, which uses radio waves rather than electric wires to transmit sound. During World War II, the Army developed radio telephones for ships, aircraft, military vehicles, and field use. After the war, the telecommunications industry began developing mobile telephone service for non-military use. But the Federal Communications Commission, or FCC, dedicated much of the radio spectrum to television, leaving few airwaves available for mobile communications. In 1947, Bell Labs engineers proposed the idea of reusing the limited radio frequencies. They outlined a system in which large areas were broken into zones called cells. A low-powered radio antenna or tower would serve each cell. Calls would go from tower to tower as a caller roamed with a phone. But this proposed cellular concept was ahead of its time because it required technology that did not yet exist. 20 years later, the FCC made room on the airwaves for cell phones by designating underused television channels for mobile communications. Within the next decade, AT&T and Bell Labs were ready to test their cellular service for 2,000 customers in Chicago. After trials in other cities, the FCC authorized commercial cellular service in the spring of 1982. Most of the first mobile phones were installed in cars because they were too bulky to carry. In the 1990s, microchips helped make cell phones pocket-sized and much less expensive. Today's cell phones have evolved into small electronic devices with many features. Besides making calls, people text message, play games, check email, or browse the internet from their phones. In 1878, Bell wrote, "I believe in the future. Wires will unite the head offices of telephone companies in different cities, and a man in one part of the country may communicate by word of mouth with another in a distant place." Bell's vision has been realized. The wires, however, are optional. Another great invention triggered a revolution in communications. This tiny transistor made it possible to create portable radios, personal stereos, MP3 players, computers, and even space travel. In the 1940s, television sets were as bulky as washing machines. Radios were too big to carry, and computers filled entire rooms. That is because they all ran on vacuum tubes. Vacuum tubes work by controlling the movement of electrons in a space that is empty of matter, or a vacuum. Their ability to control electrons makes them useful as switches. When a vacuum tube receives a control signal, it generates an electric current. When the signal stops, so does the current. But vacuum tubes were unreliable because they often burned out. They also consumed large quantities of power and generated a lot of heat. Vacuum tubes were large and could not be miniaturized. At the end of World War II, a team of researchers, William Shockley, John Bardeen, and Walter Brattain, began developing a semiconductor switch, or a transistor, to replace vacuum tube technology. A semiconductor is a substance that conducts electric current better than an insulator like rubber, but not as well as a conductor like copper. The first semiconductors were made from the element germanium. Today, most transistors have silicon semiconductors. When they are cooled, semiconductors act like insulators and do not conduct current. When they are mixed with some impurities, they conduct more current. Because they can be made to conduct current or not, they can be used as switches in computers and as amplifiers in sound equipment. After repeated trial and error, Shockley, Bardeen, and Brattain found success in 1947. They amplified an electric current when it came into contact with a germanium crystal semiconductor. This amplification became known as the transistor effect. And in 1956, the team received a Nobel Prize in physics for their discovery. Transistors quickly became the key component of almost all electronic devices, including radios, telephones, and computers. Produced as individual components, transistors were connected to other electronic components to make up transistor circuits, which were smaller, faster, and more complex than vacuum tube circuits. But transistor circuits had their limitations. Individual components were made separately and connected one at a time. Making the circuits became a laborious and expensive process with unreliable results. In 1958, the engineer Jack Kilby, who specialized in electronic circuits, tackled the problem when he began working at Texas Instruments.
The answer was to make all of the components that were required in a single semiconductor.
Kilby proposed that the entire electrical circuit, including transistors, could be made out of the semiconductor material itself. Kilby received a patent for miniaturized electronic circuits in 1959. At the same time, Robert Noyce developed a similar device called the unitary circuit for the Fairchild Semiconductor Corporation in California. Noyce went on to co-found Intel, the company best known for the microprocessor, a device found in most modern computers. Today, Noyce and Kilby are considered co-inventors of what has become known as the integrated circuit. Kilby and his colleagues at Texas Instruments put the power of the integrated circuit to use in 1967 when they invented the first handheld electronic calculator. Kilby and Noyce laid the groundwork for modern microchip technology when they proved that large, complex electronic components could be miniaturized on semiconductors. The microchip, a small piece of silicon that holds a large number of integrated circuits, has made countless innovations possible. Almost every modern device using electricity contains a microchip. In a span of 60 years, engineers have made extraordinary advances in electronics. Yet little has changed in the fundamental design of microchips over the past 30 years or so. Today, single microchips hold millions of transistors, and they all fit on the tip of a finger.
Computers and the internet have revolutionized our relationship to information. Today you can hold an entire library of books, media, and music in your own computer. Imagine a day when magazine racks, bookshelves, and newspaper bins are obsolete in favor of remote servers and information storage devices that fit in the palm of your hand. I'm gonna miss you.
Every day, people around the world use computers at school, at the office, and at home. Computers have become a pervasive part of modern life. We use them for a variety of reasons, but computers were originally designed, as their name implies, for computing or performing mathematical calculations. The abacus is the earliest known calculating device, dating back to at least 1100 BC. Each bead below the crossbar of the abacus represents the number 1. Each bead above the bar represents the number 5, or the number of fingers on one hand. You can think of the abacus as an early digital calculator. In the early 1800s, people developed mechanical calculators to do mathematical calculations. They referred to these devices as thinking machines. In 1821, an English mathematician named Charles Babbage invented a mechanical computer called the difference engine. The machine added numbers that had as many as 31 digits. Babbage created plans in 1834 for another computer, which he called the analytical engine. This machine was never completely built, however, because the necessary technology wasn't available at the time. Regardless, the theory behind the analytical engine represented a huge step forward. Babbage envisioned a machine that was programmable and, like the computers to come in the 1970s, operated on punch cards. While working at Bell Labs in 1937, George Stibitz designed the first electrical digital computer, called the binary adder. From a few discarded relays or wires, batteries, contacts, or strips of metal and indicator lights made from flashlight bulbs, the machine used binary code, or binary counting. In binary counting, any number can be written as a 1, a 0, or a series of ones and zeros. The computer is directed to each next step through a system of ones and zeros. It's a little like a walk or don't walk sign. Stibitz began building the first complex number calculator in 1939, and this circuit could add, subtract, multiply, and divide complex numbers. Unlike the binary adder, the complex number calculator used more than 400 connected relays. He demonstrated the machine in December 1940. The first general-purpose electronic digital computer, the ENIAC, was built in 1946 for the United States Army. ENIAC, short for Electronic Numerical Integrator and Computer, was an enormous machine that filled a room the size of a school gym. Working together, John Mauchly and J. Presper Eckert designed ENIAC. According to legend, ENIAC used so much power that all the lights in Philadelphia flickered when it was turned on for the first time on February 14, 1946. Even though ENIAC represented a breakthrough in electronic computing, it had limitations, including its large size and minimal programming capabilities. The machine had to be reconfigured manually in order to switch it from one program to another. Princeton mathematician John von Neumann first published the idea that it could be possible to tell a computer what to do without rewiring it for different applications. He theorized that the computer program and the data the program acted upon could be stored in the same memory. In 1951, Mauchly and Eckert, working with the private company Remington Rand, designed a new computer for the U.S. Census Bureau. They called it UNIVAC. It received major attention when it aided pollsters in predicting the winner of the 1952 presidential election. Early computers used mechanical on-off switches, but by the time ENIAC was built, vacuum tubes replaced mechanical switches. The vacuum tubes were faster, but they were large, hot, and unreliable. The invention of the transistor at Bell Labs in 1947 made computer switches faster, smaller, and more dependable. Engineers in the 1960s created an integrated circuit by connecting many transistors. Integrated circuits enabled faster and more versatile computing. In 1964, Douglas Engelbart introduced a new way to communicate with computers.
I don't know why we call it a mouse. Sometimes I apologize. It started that way, and we never did change it.
Engelbart's mouse made computers more user-friendly and paved the way for interactive tools such as the Windows operating system and the Internet. In fact, Engelbart was a member of the team in 1965 that created ARPANET, the first network of 4 computers. Within 20 years, ARPANET was the first transmission network to employ Transmission Control Protocol/Internet Protocol, or TCP/IP. This allowed ARPANET to communicate with other independent networks of computers, creating one big network, the Internet. In 1989, Tim Berners-Lee changed the world of computers by creating the World Wide Web, which allowed Internet users to access and share information. Berners-Lee developed hypertext markup language, or HTML for short, to create links between online documents or web pages. This easy-to-use information retrieval system debuted in 1991, and within 5 years, the number of Internet users jumped from 600,000 to 40 million. By 2006, more than 147 million American adults were online. Computers will continue to change with advances in fiber optics or the transmission of signals through glass carriers. The largest copper wire network can transmit only 45 megabits or 45 million bits of information per second. But a fiber optic network can carry more than 10 gigabits or 10 billion bits of data per second, sending information almost instantaneously. Computers have become so commonplace that technical terms once used only by computer scientists are now part of everyday language. Modern computers do so much more than compute numbers. The Internet, email, and the World Wide Web have created a communication superhighway that connects millions of people every day.
Inventing isn't just for nuclear physicists and PhDs. You can be an inventions pioneer by putting your ideas to the test. Up next, meet our student scientist inventor, Jay. He studies communication methods to see if his messages are coming in loud and clear.
Jay wanted to learn more about electrical communication, so his experiment involves testing a home power line network for noise.
A home power line network is a network that uses the existing power outlets and power wiring of a house to allow computers to connect to each other.
Sometimes this network runs alongside DSL connections that travel on standard telephone wires.
So I wanted to see if the power line network could be interfering with my DSL connection and affecting my speeds.
To do that, Jay had to create a special test network.
You can think of this network as being one big circle where everything flows to each other. This computer connects to this device down here through this cable. This wire travels back through here into the power of the building.
Through a series of cables and special adapters, Jay creates a network that enables two computers to talk to one another. In order to measure how much noise this network can cause in neighboring telephone wires, Jay introduces several other components.
I ran a power extension cord for 25 feet along a telephone wire, also 25 feet. I also plugged the telephone wire into the oscilloscope so that I could measure the noise.
To activate the network, Jay performs a simple file transfer from one computer to the other. As the signal passes through the network, the oscilloscope begins to react.
This makes it clear that crosstalk is occurring from the power network onto the phone line.
By observing the oscilloscope, Jay is able to collect data and draw his conclusions.
This amount of noise is actually only a few hundred microvolts of noise. So while I did find noise in my telephone wire, as I predicted, it was not enough to cause a significant interference.
The cell phone is a convergence of two major technologies, radio and telephone. Without this invention, you'd be stuck in the same room for an entire call. Imagine that. Whoa! Whoa! Whoa!
Modern life wouldn't be the same without radios, microwaves, cordless phones, remote-controlled toys, or television broadcasts. All of these devices, including cell phones, are made possible thanks to radio waves, the electromagnetic waves that transmit music, speech, pictures, and other data through matter in space. Radio waves are electromagnetic waves that can be identified by their wavelengths and frequencies. Wavelength is the distance from the top of one wave to the top of the next, and frequency is the number of waves that go by in a second. In the U.S., the Federal Communications Commission determines frequencies for different purposes. Some are assigned to radio and others to television stations. The frequencies range from about 500,000 to about 3 billion hertz, or cycles per second. Radio waves are sent from a transmitter to individual receivers, which have tuners to separate the frequencies. Antennas used with transmitters and receivers extend a broadcast area. The discovery of radio waves and the invention of radio transmission technology freed electronic communications from the tethers of wires. The Scottish physicist James Clerk Maxwell first predicted the existence of radio waves around 1860, when electronic communication still relied on a network of interconnected wires. Heinrich Hertz, a German physicist, studied Maxwell's theories. In the 1880s, he became the first person to transmit electromagnetic waves in a lab. The Italian physicist Guglielmo Marconi began experimenting with radio waves in his family's villa as a teenager. He successfully transmitted radio waves from one end of the room to the other. In 1896, 22-year-old Marconi sent Morse code signals from his house in Bologna, Italy, to a field 1.5 miles away. That year, he also obtained the British patent for his device. Marconi founded the Wireless Telegraph and Signal Company in 1897. The following year, he set up the world's first commercial radio factory in Chelmsford, England. The building still stands there today. Marconi brought radio to the United States in 1899 when he set up an experimental radio station in Highlands, New Jersey. He wanted to broadcast the results of the America's Cup race directly to the New York Herald newspaper. His greatest communications breakthrough came on December 12, 1901. Battling stormy weather, Marconi successfully transmitted a radio signal from Poldhu, Cornwall to St. John's, Newfoundland, some 2,000 miles across the Atlantic Ocean. But others, like Reginald Fessenden, who once worked for Thomas Edison, were more interested in developing the wireless transmission of voice and sound. Fessenden startled telegraph operators on Christmas Eve 1906 by transmitting music and his own voice from his lab in New England to ships miles from shore. Soon, amateur radio enthusiasts called ham operators, or hams, were filling the airwaves, broadcasting experimental programs from their homemade radios. While people were exploring the broadcast capabilities of radio, Marconi focused narrowly on ship-to-shore communications and dominated the transatlantic wireless telegraphy industry in the early 1900s. The loss of life on the Titanic in 1912 could have been worse if the ship's radio operators hadn't used Marconi's wireless telegraph to send distress signals. Grateful Titanic survivors presented Marconi with a solid gold medal amid cries of "Ti dobbiamo la vita," which means, "We owe you our lives." In the wake of the Titanic disaster, countries convened at the International Radio Telegraphic Convention in London, England, to establish regulations governing wireless services aboard ships and on shore. The United States government also established the Radio Act of 1912, which prevented amateur radio broadcasters from transmitting over military or commercial frequencies. This act required all ships carrying 50 or more people sailing in American waters to maintain continuous 24-hour radio operation. Between 1920 and 1940, radio grew into an industry, establishing a mass audience for its programming. It was the first communications medium that brought large numbers of people together to experience and share news, entertainment, and events as they were happening. Popular radio stars influenced the way Americans talked and thought. Advertisers found a captive audience for their products. Radio broadcasting brought more than families together in their living rooms, it brought a nation together. For the first time in history, the whole country could experience the same entertainment and news. People all over America listened as President Franklin Roosevelt tried to soothe the nation with his fireside chats during the Depression, and the population connected as millions turned to their radios for news during the Second World War. By the 1930s, engineers had figured out a way to broadcast pictures as well as sound wirelessly over electromagnetic waves. As television became more popular, many people thought it would mean the death of the radio. They were wrong. Radio programming changed, and popular music, especially rock and roll, became its mainstay for decades. Edwin Howard Armstrong developed FM, or frequency modulation, in 1933. FM radio receivers reduced static and provided a more clear audio signal than AM, or amplitude modulation, which was the standard. But FM had a limited transmission range, making it impossible to hear a radio station while traveling far from a station's transmitter. Satellite radio changed this. Ground stations beam radio signals to satellites in space, and the satellites transmit the signals back to radio receivers on Earth. This type of radio offers uninterrupted service nationwide without loss of signal quality, regardless of the distance from the transmission source. The use of wireless radio technology continues to evolve and grow. Modern advances in cell phones, global positioning systems, and wireless internet have created a mobile society that communicates just about anywhere on the globe. Guglielmo Marconi sent an invisible transmission across the room more than 100 years ago. In many ways, it is echoing around the world today. Radio was a technological marvel that allowed words and music to be transmitted over the air and over great distances. The next step was to send pictures that way, too. Most inventions begin with a vision. But one invention in particular ends with a vision as well. The television. The first televisions worked by breaking a scene into smaller pieces, much like they do today. However, they did so mechanically. German undergraduate student Paul Gottlieb Nipkow conceived of the first mechanical television in 1884. His device featured a metal disc called a spinning wheel with a series of holes punched in a wide spiral pattern around the outside. As the disc rotated, the holes moved across the scene, scanning the image. Different amounts of light passed through each of the holes in the disc. The light was then translated into electrical current and sent through a wire to a receiver, where it was converted back to an image. Mechanical television enabled the transmission of images, but its many moving parts made it impractical for commercial use. A 15-year-old farm boy named Philo Farnsworth thought of a solution to this problem. He decided to scan images electronically. According to legend, he came up with the concept of electronic television scanning in 1921 while plowing a potato field. Farnsworth realized that his plow created long, unbroken lines in the dirt, and that perhaps images could be scanned in long, unbroken lines as well. At the age of 22, Farnsworth patented his electronic image scanning tube. This was, in essence, a cathode ray tube, a device used in all televisions up until the late 20th century. Light would strike the front of the tube and leave behind an electric charge. A beam of electrons moved back and forth by electromagnets, scanned the tube from behind, and turned the image into a stream of electric current. In September 1927, Farnsworth gave the first demonstration of electronic television. Like mechanical television, Farnsworth's invention used a transmitter to turn light into electrical signals and then send those signals to a receiver where they turned back into light to form an image. Vladimir Zworykin, a Russian engineer, also developed a television transmitting and receiving system using cathode ray tubes. He called his transmitting tube an iconoscope and his receiving tube a kinescope. While Farnsworth and Zworykin developed their own versions of electronic television, Zworykin had something Farnsworth did not have: the power and money of RCA behind him. RCA was already the leader in radio broadcasting, but David Sarnoff wanted the company to be the leader in this new medium as well. After 10 years and millions of research dollars, Sarnoff was ready to unveil television at the 1939 World's Fair in New York City. Franklin Delano Roosevelt became the first president to speak on television when his opening remarks were broadcast by RCA. By 1949, millions of television sets had been sold, and black and white TV was a huge commercial success. The general public could watch broadcasts over the air via radio waves, which transmitted video and audio signals through open space. Antennas were required to transmit and receive television signals. However, mountains got in the way of some signals, and many signals did not reach rural areas. To address this problem, cable television was developed in the 1950s. It provided the audience with programming through fixed cables rather than transmitting signals via wireless radio waves. Not only did the 1950s bring about improvements in television transmission, there was also the introduction of a more lifelike picture. The first generation of color TV sets hit the market in 1954. As color televisions became household fixtures during the 1960s, AT&T, with the help from NASA, launched Telstar 1, the first commercial communications satellite. Satellite technology broadened television's audience by allowing remote places on Earth to receive television signals. The more popular television became, the more television receivers advanced. In the past 50 years, televisions have evolved from bulky floor models with small screens and grainy black and white images to sleek, high-definition models with flat-panel plasma screens. No one can be sure how television will change in the future, but one thing is certain: audiences will stay tuned. Now that you can watch television shows on the internet, do you think traditional TV will become obsolete? It's time for Before You Know It, when we step across the cutting edge of technology and glance into the future of invention. We sent students to Wired Magazine's Next Fest in New York City to witness and experience some emerging technologies for themselves. At Next Fest, companies showcase technologies that are transforming our world. Today, we'll check out advances in communication. People interact with news and other media every day, but a new invention called the media mirror interacts with you in a new way. The media mirror uses more than 200 live cable feeds to form a shifting mosaic image of the person standing in front of it.
Yeah, if you notice, some of them are animations of people walking and stuff.
Created by Jeff Hahn, a research scientist for New York University's Department of Computer Science, this invention illustrates the idea that people shape media just as media shapes people.
But the camera has to decipher which color is which, and the lighter colors have like that little box. Right. Yeah. I guess one color is for like certain photos.
Our students went from interacting with the media to interacting with robotic pets. The Paro seal acts just like a live pet, providing companionship and comfort to those who are unable to take care of a real animal.
Yeah, well, this kind of.
Crying. Now, are there like sensors run, or does it just have like a schedule?
The Paro seal has an audio sensor that enables it to learn and recognize words frequently used by its owner. It changes its mood based on how it's treated.
I don't like that. Why are you telling me to do something the seal doesn't like?
I really want one. I would give it to someone as a gift. I don't know, my mom.
Mom?
I got you a pet seal.
That concludes this edition of Before You Know It. But before you know it, it will be time for another edition. You're right. I couldn't agree with you more. That's good. Oh, listen, I gotta go. Yeah, okay. You barely have to lift a finger to get in touch with a friend on the other side of the world. But that wasn't always the case. Our ability to communicate has grown right along with our capacity to explore the ocean floor and break the sound barrier. Communication isn't just the way we express our ideas, it's how we bring those ideas to life. How would Einstein have developed his theory of relativity if he couldn't write it down? And how useful would it have been if he couldn't tell anyone about it? Today's communications inventions connect people and ideas with amazing clarity and speed. But sometimes it's nice to unplug for a while. I'm Bill Nye, and thanks for joining me on Greatest Inventions in Communications. Talk to you later. Tune in next time as we watch the evolution of transportation. From the first wheel to the steam engine to cars that run on fuel cells, the world moves forward thanks to developments in transportation. Next on Greatest Inventions with me, Bill Nye.